Okay, in this video we're going to do some more with functions. So the first thing we're going to look at is how to find the domain of a function given the equation. We'll also do a little bit of how to do it with a graph again. I know in the previous video we did some finding the domain. And then we'll finish things up with doing a little bit with piecewise defined functions. So the domain of a function y equals f of x is the set of all real numbers for which f of x is defined, which for us means the denominator is not 0, and real, so we're not going to get any complex numbers. So that's going to be the radicand is the thing under the square root that is greater than or equal to 0. So to find the domain of a function, we're going to go ahead and assume that the default is minus infinity to infinity. Unless there's a denominator, and if there's a denominator, we solve the denominator not equal to 0. It's the same thing as finding restrictions for rational functions, rational equations. If there's a radical with an even root, so for us it's only going to be really square roots. We might do an example where something has like a sixth root or whatever. So the thing under the square root we call the radicand. And we'll solve the inequality. The radicand is greater than or equal to 0. Okay. All right. So let's not have it all displayed out there. Let's go ahead and find the domain of each function and write the domain as an interval. So first thing we'll do is look at x plus 2 over x squared minus 13x and plus 36. So when they're asking us about domain of a function and we're looking at the equation, we're looking for two things, denominators and square roots. So this has a denominator. So we take the denominator and set it not equal to 0 and hope it factors here, which it does. It factors into x minus 9 and x minus 3. No, it's not 3, it's 4. Sorry. And x minus 4. So I may have made that error, so we might have to fix that as we go along. Okay, so that means x cannot be 9 and x cannot be, yeah, so we're going to have to fix it. It should be x cannot be 4 here, okay? All right. So we'll go ahead and do our number line. And so the 4 comes first. All right, so this should be a 4. And so all those 3's will have to change to 4's here because I didn't factor it correctly. Okay, so we got to hop over 4 and 9. So our domain is negative infinity. And 2, 4. And then 4 to 9. And then 9 to infinity. Okay, and then that's the domain and interval notation. Okay, let's look at another one. We'll look at f of x equals 5 minus 2x under the square root. So this one does have a radical, a square root. So we're going to take the radicand, which is the 5 minus 2x, and solve that greater than or equal to 0. So we can plus 2x to both sides. So we have 5 is greater than or equal to 2x. We'll divide both sides by 2, divide by 2, and so we will have 5 halves is greater than or equal to x. That's the same thing as x is less than or equal to 5 over 2. And again, you just got to make sure the alligators are in the correct number. We can reverse the order. So minus infinity, infinity. We'll put 5 halves here. If you have the x on the left, the inequality is going to point to the direction, so that would be to the left. So x less than or equal to 5 halves. Sorry about that, the cat was all over me. Anyways, so when x is less than or equal to 5 halves, that's going to be to the left. If the x is on the left-hand side, the inequality will kind of point to the direction. So in terms of our domain, it's going to be minus infinity and then to 5 halves with a bracket, because we're allowed to be 5 halves, but we can't be, or we're allowed to be 5 halves. We can't be infinity because it's not a number. So bracket at 5 halves, parentheses at negative infinity. Okay. How about f of x is equal to x plus 10 under the square root over x squared plus 5x plus 6. And so we get the best of both worlds. So we have a radical, so we set the x plus 10 greater than or equal to 0. Solving that, we get x is greater than or equal to negative 10. And then we have x squared plus 5x plus 6 cannot equal 0. X plus 2, x plus 3, that cannot be 0. And so that tells us that x cannot be 2 and x cannot be, negative 2 and x cannot be negative 3. Draw your number line, minus infinity to infinity. Negative 10 and negative 2, negative 10, negative 3, and negative 2 are the numbers we're interested in. We cannot be negative 3 and we cannot be negative 2. And x greater than or equal to negative 10. So the x is on the left-hand side, so this would tell us what direction we'd go to the right. Okay, so we're going to go from minus 10 to 3. Got to hop over the negative 3. So domain, bracket negative 10 to negative 3, union negative 3 to negative 2, union 2 to infinity, negative 2 to infinity. Okay. All right, well, let's look at another one. F of x is equal to the fifth root of 2x plus 5. So only even roots are going to cause problems. The fifth root, not a problem. Seventh root, not a problem. 2x plus 5, that's a polynomial, not a problem. So the fifth root has no problems. And the 2x plus 5 has no problems. Problems being dividing by 0 or taking square roots of negatives. So we don't have either one of those. And so the domain is all real numbers. Negative infinity to infinity. Okay. All right, so let's move on, and I think we're going to look at some a question that's kind of like a review question. So f of x is equal to 3x minus 18 over x squared plus 4x and minus 12. So you're going to have one or two of these on the homework. Usually I put one kind of like this on the test. And they're going to just ask you a bunch of questions, okay? So first question they're going to say is the point negative 6, 0 on the graph? And so what we want to do is plug in the x value of negative 6 and see if we get the y value of 0. So f of negative 6 is 3 times negative 6 minus 18 all over negative 6 squared plus 4 times negative 6 and minus 12. So it's going to be negative 18 minus 18 all over 36 minus 24 and minus 12. So the top is going to be negative 36 and the bottom is going to be 0. Dividing by 0 doesn't make sense. It's going to be undefined. Okay, undefined is not the same thing as 0. And so, because we don't get 0, we get undefined, that means that negative 6, 0 is not on the graph. If it got undefined anyways, it would not be a point on the graph. Okay. Another question they may ask you is they say, okay, tell me what the domain is, okay? So this has a denominator, so we're going to take the denominator and solve it not equal to 0. So this will factor into x plus 6 and x minus 4. I'm sorry, x plus 6 and x minus 2 is the correct factoring. So x cannot be negative 6 and x cannot be 2. So for our domain, that's negative infinity to negative 6, union negative 6 to 2, and union 2 to infinity. Okay, and you can certainly do the number line if you like. So here's minus infinity, here's infinity, and we have to hop over negative 6 and 2. And so the number line kind of helps with, you know, if you, a lot of times that middle interval here, minus 2 to minus 6, gets skipped over on accident. Okay, so there's your three intervals. Okay, we're going to continue on with the same function and do some more questions with it. So we'll go ahead and write that equation down again, or function. 3x minus 18 over x squared plus 4x minus 12. So we're going to find f of minus 5, so that just means to plug in negative 5 in for the x. So 3 times negative 5 minus 18 over negative 5 squared plus 4 times negative 5 minus 12. It's going to be negative 15 minus 18 all over 25 minus 20 minus 12. So it's going to be negative 33 over negative 7, which is 33 over 7. Okay. Then when does a fraction a over b equal to 0? Well, what we can do is we can take that fraction, it's equal to 0, and multiply by the common denominator, which is b. So we'll multiply both sides by b, and that says a is equal to 0. So when does a fraction equal 0? That's when the top equals 0, when the numerator equals 0. Okay. So if I ask you for what values of x does f of x equal 0, well, f of x is a fraction, and if we have a fraction equal to 0, that means where the top is equal to 0. So that means where is 3x minus 18 equal to 0? Well, you would add 18 and then divide by 3. You would add, well, let's go back. You would add 18 and then divide by 3, and you get x is equal to 6. So that would be the x value there. Okay, we're going to use the same problem, and we're going to ask for what values does our function equal, what values of x does our function equal minus 1? Okay, now this time we won't be able to just set the top equal to minus 1. It's special if it's equal to 0. Okay, so minus 1 is equal to 3x minus 18 over x squared plus 4x and minus 12. Common denominator here is x squared plus 4x minus 12, and so we're going to multiply both sides of the equation by that to clear the fraction. So we have minus x squared minus 4x and plus 12 after we distribute the negative 1. On the right hand side, the factors of x squared plus 4x minus 12 will cancel or absorb, and so you're left with 3x minus 18. This is a quadratic, so we want to set it equal to 0 and hope it factors. It's easier to factor if the x squared term is positive, so we're going to add x squared, we're going to add 4x, and we're going to subtract 12. And add x squared, and add 4x, and subtract 12. So we have 0 is equal to x squared plus 7x and minus 30. This factors into x plus x minus 3 and x plus 10. So then that tells us that x is equal to 3 or x is equal to negative 10. So if we plug in either of those values into our function for x, the output of the function is going to be minus 1. Okay, the next thing we're going to do is we're going to look at some examples of finding the domains. We did a little bit of that on the last video for section 3.1, so we're going to do it again. And we had some kind of crude drawings. So here I've taken some screenshots of the graphs that are in the notes there. So number 6, we have some sort of kind of like partial. They're both 6 and 7 look like some sort of partial pieces of parabolas there. And we're going to find the domain and the range. Okay, so the domain is going to be the far left to the far right, or beginning to end. So it looks like it's going to start at minus 5. And then stops at 1, okay? So start at minus 5, stop at 1. Now, at minus 5, we have a filled-in dot, so that will be a bracket, which means we're including that. And then a parentheses at 1, because it's an open circle, so that means we're not including 1. Okay, now the range is low to high, or bottom to top, so how low to how high? Okay, so the range, the bottom is minus 4, that's how low it gets. And the highest it gets on the y-axis is negative 2. Okay, it does achieve the value of negative 4. It's touching negative 4, so we'll include that. And then for the minus 2, on one side it's filled in, and on the other side it's open. Because it's filled in on one side, we can go ahead and include it. The range does take on that value of negative 2. Okay, for number 7. The domain, we start at negative 2 and we stop at 1. and then it's a filled-in dot at -2 and a open circle at 1. So we're going to have brackets at -2 and parentheses at 1. And for the range, the lowest it gets is 0, and the highest it gets is, it looks like it gets all the way up to 4. And it looks like it takes on both values of both 0 and 4, so we will include brackets on both of them. Okay. All right, the last thing we're going to take a look at is piecewise defined functions. So possible example of piecewise defined function would be, maybe like your electric bill or something like that. So maybe you play a flat rate for a certain amount of wattages, and then once you exceed that amount, then they may, so you might be paying a flat rate, and then once you hit a certain amount, then they start charging you per watt or something like that. Maybe a phone bill, you pay a flat rate, and then afterwards they start charging you for data, so it changes the shape of the graph. So we're going to look at a couple examples of these piecewise defined functions. So we'll evaluate a piecewise defined function or two, and then we'll also graph them. Okay, so here we got f of x is equal to 1, 2, or minus x, depending on if x is less than 0, x is equal to 0, or x is greater than 0. Part A is going to say, all right, well, what is f of minus 1? Minus 1, that is less than 0, so we're going to use the first function, which just gives us an output of 1. -1 is less than 0, so the output is 1. And then we can go ahead and plot that point here. -1 and 1. Part B says, okay, well, let's find f of 0, and that's going to fall here. 0 is equal to 0, and the output of the function is going to be 2. So we can plot the point 0 and 2. And finally, part C, let's go ahead and find f of 3. 3 is greater than 0, so we're going to use the third one. Okay, so here we're going to use the third one, which means to take whatever you're feeding it and make it negative. Okay, so that gives us the point down here. Oops, if I can try to draw on it. There you go. This point here. Okay. Now, when x is less than 0, the function is always 1. So you see, I've drawn in all 1 here, and it's going to do that all the way until we get to 0. So we're all the way to 0. But at 0, it is a less than, so it's a strict inequality, so we'll have an open circle there. We got the point 0, 2, and then the last part is this x negative x, okay? And we're going to start using that at 0, and so we could do like a little t-chart if you wanted to. So x and minus x, so we'll do our t-chart. We can start it at 0, so 0, 1, 2, 3. That might be enough. And all this does is makes it negative. 0, minus 1, minus 2, minus 3. Because this is a strict inequality, you're going to have an open circle at 0, 0. Okay? So we can do that and plot those points. And then connect our connector dots. Okay? So it is 2 line segments and then a singleton point at 0 and 2. Okay, we're going to go ahead and look at one more. Okay, so here we have f of x is equal to x squared if x is less than minus 1, or it's equal to 2x plus 5 if x is greater than or equal to minus 1. So we're going to practice evaluating f of minus 3. Minus 3 is less than -1, so we're going to use the top branch, which is x squared. It's going to be -3 squared. That's going to be 9. And then I can plot that point of -3, 9 over on my graph. Part B, f of -1. So -1 is not less than -1, so we won't use x squared, but -1 is greater than or equal to -1, so we'll use the 2x plus 5. So 2 times -1 plus 5, that's going to give us 3. So I can plot the point -1 and 3. And then one more part C, f of 0. 0 is greater than or equal to minus 1, so we're going to use the 2x plus 5. So 2 times 0 plus 5 is 5, okay? Excuse me. So the 2 points we got there, 2x plus 5 is a line. That's enough to graph that there, okay? Now the thing with the parabola here, I can make a little t-chart. So we can do x and then x squared. So we have to stop using it at minus 1. So maybe we'll do minus 1, minus 2, minus 3. Square those. 1, 4, and 9. Okay? At minus 1, that's where we stop using it because it's a strict inequality. X is less than negative 1. Open circle there. And then we can also plot the point negative 2 and 4. And then connect our dots in a parabola there. Okay, so that is it for section 3.2. A little bit of overlap with 3.1, so get a little bit more review there of some properties of functions.